Alright, let's talk about partial differential equations. We are going to start talking about partial differential equations by talking about partial integration. Uh, in calculus, actually, we have total differential, we have total differential, and we have partial differential. So if I write dy dx, that's the total differential. And if I write partial y partial x, which is the partial derivative of y with respect to x, and that's the partial differential. Now, talking about partial differential equations, we're talking about differential equations that involve one or more of its partial derivatives. I want to solve the differential equation. The second partial derivative of mu with respect to x equals 6x into 2y minus 1, given the boundary conditions that at x equals 0, partial u partial x equals sine 2y and u equals cos y. Now, this is how we solve. The equation is the second partial derivative of u with respect to x is equal to 6x into 2y minus 1. Now, if I have d squared y dx squared, this means that I differentiated y two times with respect to x. So if I want to get y from there, I'm going to integrate this two times to get y. So I have the second partial derivative of u with respect to x. So if I integrate this once, I'll be left with partial u partial x. That is what I would get upon the first integration. So let me say integrating with respect to x, I'll get this. And the integral is, and partial u partial x equals the integral of 6x into 2y minus 1 dx. That's the integral setup. Now, this is a function of two variables, x and y. But the integration is with respect to x. That means I will consider y a constant. So all functions of y will be considered a constant in this case. That's what I'm saying. This is the function of x here. So every other thing here will be considered a constant. I can bring this outside the integral to be 2y minus 1. 6 is always a constant, so it can come out as well. Then having the integral of x with respect to x, and that's the setup. So this is it. Let's go. We have 6 into 2y minus 1. By the rule of integration, if I integrate x with respect to x, the rule says add 1 to the power. This is x raised to the power 1. So I'm going to add 1 to it, then divide by the sum, which is 2. So this is actually x squared all over 2. Now, when we perform integration, we normally add a constant of integration. That is for total differential. Okay, if I do the integral of x squared dx, it is s cubed over 3 plus c, where c is the constant of integration. That is when we are doing total differential. But for partial differential, we don't add a constant of integration. We integrated, or we're integrating with respect to x, and as a matter of fact, we consider the other variable y as a constant. So I am going to add a function which will be serving as the constant of integration in this case. Again, the function will be a function of the constant, which is y. It could be f of y, it could be g of y, it could be anything. But whatever it is, it must be a function of y. That's the point. So this is what I said. I will perform this integration. The variable that was considered a constant in this case is y. So I will add a function of y to the integral I got. So if, for example, we had integrated with respect to x, with respect to y, that is, we now consider x as a constant. It means that this will be f of x. You get it? So at this point, let me see, this is equal to partial u partial x. Now, let's apply the boundary conditions to determine what f of y is. They say that at x equal to 0, partial u partial x equals sine 2y. So I'll just say at x equals 0 and partial u partial x equals 2y. I will, anywhere I see x here, just write a 0 and replace this one with what? Sorry, this is sine 2y. Sine 2y. So I'm going to say sine 2y is equal to, we have f of y plus, tell me, if 0 enters here, if this is 0, everything here becomes 0. And if you use 0 to multiply every other thing, everything turns 0. So as a matter of fact, 0 is left here. Okay, so what this means is that f of y equals sine 2y. Alright, so I want to write it here because of my space. F of y equals sine 2y. So this is the equation now. This is it. I'll say partial u partial x, which is the partial derivative of partial u partial x, which is the partial derivative of u with respect to x, is equal to 6 into 2y minus 1 into x squared over 2. But check, 2 can divide 6 to give me 3. So I can write 3 here. Right? That will be 3x squared into 2y minus 1 plus, what's f of y? From our calculation, f of y is sine 2y. So we have sine 2y. Alright, let's keep this. Remember, we got this equation by performing integration. We integrated with respect to x. We've done one integration. Now, the order in this differential equation, it was of order 2 because we had partial square u partial x squared. Now, the order has reduced to 1. So what this means is that to get u, I will have to do one more integration. Yeah, to get my u, I'll have to perform one more integration. See, this is what we're going to do now. I'll say integrating, because I'm having partial x here. This is the second derivative of u with respect to x. That is why we integrated with respect to x, because we have this. So we still have partial u partial x here. I'm going to integrate with respect to x again. And let's see what that will be. If I integrate partial u partial x, I'm going to get u. Yeah. And this is equal to the integral. I'm going to integrate this now. The integral of everything here. We have 3x squared into 2y minus 1 plus, okay, dx plus, take note, we always use total differential for this. The question is partial integration, but when we are integrating, we use the total differential for it, dx, not partial x, plus the integral of sine 2y dx. Now check. 3 into 2y minus 1 will be considered a constant. Okay. I'll bring this out 3 into 2y minus 1. Now I'm going to integrate x squared with respect to x. And that will give me x cubed over 3. I added 1 to the power, which is 3, and then divided by that same 3. Plus, check. This is sine 2y. It is purely a function of y. And whereas we are integrating with respect to what? To x. It means that sine 2y will be considered a constant. So I'm going to bring sine 2y outside. So if I bring sine 2y outside, it's like writing it like this. I'll say sine 2y to the integral of what? Dx. And you know that the integral of dx is also the integral of 1 dx, right? 1 is a coefficient. So if I integrate 1 with respect to x, that will give me 1x. Check it out. This is 1x to the power of 0. Of course, they are the same thing. So if I want to integrate this, it's just to add the 1 to it, then divide by 1. And everything here is equal to what? X. So if I integrate ds, or 1 dx, I'm going to get x. So that x now is going to multiply sine 2y to give me x sine 2y. When we perform this integration, we added f of y. And the reason for adding f of y is that the variable considered as a constant in this step or in this integration is y. So it is still y that is considered a constant here. I'm going to add another function of y. Now it is not going to be f of y. I can choose g of y. I'll say plus g of y. If you add f of y, you are going to be wrong. Yes, you use another function, not f in this case. It could be g, h, or whatever, but they should not be the same. So we now apply the boundary conditions finally to get our g of y, and that settles everything. So we have u is equal to 2y minus 1. We have 2y minus 1 into x cubed into what? X cubed plus x sine 2y, then plus g of y, plus g of y. Alright, this is we need to get g of y before we conclude. Now, the boundary condition that was given to us says that given that at x equal to 0, partial u partial x is sine 2y. We have used this one before. So at the same x equal to 0, u is cos y. So what this means is that, let's go. At x equal to 0, u equals cos y. So look at it. U is cos y, place cos y here. Then x is what? X is 0. If I plug in 0 here, everything here becomes 0. Everything here becomes what? 0. This becomes 0. Then I'm left with my g of y. So what does this mean? This implies that g of y is equal to cos y, right? So that is it, cos y. So what is now the solution to the differential equation that we're given? This is the solution. U is equal to 2y minus 1 into x cubed plus x sine 2y plus g of y, which is cos y. Paying attention to the second question, we have to solve the second partial derivative of u. Okay, look at it. This is a mixed partial derivative. This is the partial derivative of u first with respect to t and then with respect to x. That's how it is read. So it means that we are first of all going to integrate this with respect to t. Then the next integration will now be with respect to x. Okay? Given the boundary conditions as it is written, we have partial square u partial s partial t equals sine x plus t. Remember, let's integrate the first one with respect to t. So integrating first with respect to t, I'll be having partial square, sorry, I'll be having partial u partial x. Take note, I have integrated with respect to t, so this partial t is going to disappear from here. It means I have the integral of sine x plus t dt, because the integration is with respect to t. That's the meaning. Now, how do I integrate this now? You know, if I have something like, I have, let's say, sine 2t. I want to integrate this with respect to t. What does the rule of integration says? Basically, if I have the integral of sine kx dx, if I integrate the sine function, differentiate sine to get cosine, integrate sine to get negative cosine, I'm going to get negative cosine of kx. Then the rule says divide by, you see this kx, differentiate it. What will you get? If I differentiate kx with respect to x, I'll get k. As a matter of fact, if I differentiate 2x with respect to x, I'll get 2. Then we add the constant of integration, right? So in this case now, I have sine x plus t. We are considering x as a constant. So if I want to integrate this, it will be integrate sine, we got what? Minus cosine. Then write what is inside, x plus t. Then I'm going to divide by what now? Just like what we said here. Differentiate what is here with respect to t. Since x is not t, it means that it is the variable considered as a constant. You get what I'm saying? So we are considering x as a constant. Differentiate the constant to get 0, right? We're going to get 0. Differentiate t with respect to t, we're going to get 1. Then I'm going to add something, which is the function of x in this case now. I will add a function of x because we considered x as a constant. Since we integrated with respect to t, it means that x is a constant. So I'm writing a function of x. Let me use phi of x. You know, I told you we can say f of x, g of x, whatever. I'm using phi of x in this case. So it means that partial u partial x is equal to, everything here is 1. So I have negative cosine of x plus t plus phi of x. Okay. Then I'm going to apply the boundary conditions. I need partial u partial x and I need t. So partial u partial x is 1 when t is equal to what? 0. So I'll say when t equals 0 and partial u partial x. I like saying partial u partial x. It is the partial derivative of u with respect to x. What is it? 1. So it means that I have 1 here equals negative cosine of, look at it, if t is 0, x plus 0 is equal to x. So I just have minus cos x left, plus what? Phi of x. Alright, what's the implication? I'm looking for phi of x. So it means that phi of x is equal to 1. If minus cos x crosses, it turns to plus cos x. Good, we are there, almost there. Therefore, partial u partial x is equal to minus cos x plus t plus phi of x, and phi of x is equal to 1 plus cos x. So I can just say cos x plus 1. Now, let's finish the solution by doing the last integration. The last integration is going to be with respect to what? To x. So I'll say integrating with respect to x. If I integrate this with respect to x, I'm going to get u. Yeah, u is the variable, and x is what we are differentiating with respect to. So this will be equal to, I'm going to integrate this now, everything here with respect to what? X. So this is it. This is the integral of minus this. Let me just bring the minus outside and leave the cosine of x plus t inside with respect to x, plus this is the integral of cos x dx plus the integral of 1 dx. What will this give us? U is equal to negative. If I differentiate cosine, look at it, differentiate sine to get cosine, integrate cosine to get sine. So if I integrate cos, I'll get sine. Now, from just like what we did here, the rule is integrate this one, write it down. Then what is inside? Differentiate it. Use it to divide what you wrote. So this is s plus t. Since we are differentiating with respect to x, it means that t is the what? T is the constant. So if I differentiate a constant, I'm going to get what? 0. Differentiate x with respect to x, I'm going to get 1. So as a matter of fact, if 1 is under, let me just remove it. It's 1 that is under, because 0 plus 1 is 1. I hope you get it. Plus, if I integrate cos x, I'm going to get what? Sine. Integrate 1 with respect to x. I said it before, 1x, this is 1. Because x to the power of 0 is what? 1. So if I integrate this, is like adding 1, adding 1. And everything here is equal to 1. Is equal to x. So we now add something to it. What am I going to add? Will it be a function of x or a function of t? We considered, we are integrating with respect to x. We considered t a constant. So I'm going to write a function of t. Let's say theta of t. I added phi of x in the first case. I'm using theta of t now. Okay, let's go. Let's get theta of t by applying the last boundary condition. U is 2t. I need u and I need what? X. Look at it. U is 2t. If I plug in 2t here, this will be 2t equals x is 0. If I plug in 0 here, 0 plus t is t. So I have minus sine t. Then I have sine 0. Sine 0 is 0. Sine 0 is 0. X is 0. Then I have theta of t. So tell me, what will be theta of t? 0, 0 is out. Minus sine t will cross over and turn to plus sine t. So I'm having 2t plus sine t. You get it? So it means that theta of t is 2t plus t. So finally, this will be the solution. Just watch. This will be the final solution to this second order differential equation. Let me erase the question itself and write the solution there. So where did we come from? We came from here. This is where we are coming from, sort of. We're coming from here. Here we have this. Good. So I'm having u is equal to minus sine x plus t plus sine x plus sine x plus x plus x. Then this theta of t is everything here. That will be 2t plus 2t plus sine t. Yes, you are free to actually pause the video and make an attempt to solve this question on your own. And then you can verify the answer when you're done. Alright, this is the last question we are solving under partial integration. Don't forget to subscribe, don't forget to like, and don't forget to share this with your friends and to your classmates as well. I'm solving the second partial derivative of u with respect to x twice. This is y into 4x squared minus 1. So you know that I'm going to integrate with respect to x two times. If I do the first integration, it means that I'll get partial u partial x equals the integral of this particular function with respect to what? X. But now see, since I'm integrating with respect to x, it means that y will be considered a constant. So I'm having y outside into the integral of 4x squared minus 1 dx. Alright, let's integrate 4x squared minus 1 with respect to x. Partial u partial x, which is the partial derivative of u with respect to x, is equal to y into, integrate this, it will be 4x cubed over 3 plus, okay, minus integrate 1 with respect to x is going to be x. Since we considered y as the constant, it means that I'll be adding a function of y. I'm using h of y. So what will be h of y? I'll need the boundary condition that gives me partial u partial x and x. At x equal to 0, partial u partial x is what? Cos 2y. So this is cos 2y equals, when x is 0, 0, 0, everything in bracket is 0. 0 times y is 0. So what's left? H of y. So the implication is that partial u partial x is equal to y into 4x cubed over 3 minus x plus h of y is what? Cos 2y. Okay, now let's solve this one. That's what we are solving now. I will integrate one more time. If I integrate this, I'm going to get u equals, integrating this now with respect to x. Y will still be a constant, so y will be outside. We have the integral of 4x cubed over 3 minus x dx plus the integral of what? Cos 2y dx. Cos 2y here is a function of y. So let me write it like this. Bring the cos 2y outside and leave the x inside. Simple. So this is u equals y into, if I integrate this, I'll get, I already have it 4 over 3 before. So integrating s cubed with respect to x is s to the power of 4. Add 1 to it, 4. Then divide by that 4. You get it? Minus s, this will be s squared over 2. So that 4 can actually cancel 4. Cos 2y is a constant, leave it outside. Integrate ds, which is integrate 1 ds, you're going to get x. Plus, I'll add a function of y. Let's use p of y. You know, we are considering y a constant, so we need to add a function of y. So this is u equals y into s4, that's x to the fourth over 3 minus s to the second over 2 plus x cos 2y plus p of y. So what is p of y? I need u and I need x. They said when x is 0, u is sine y. So as a matter of fact, if x is 0, this one becomes 0. Everything becomes 0 because 0 times cos 2y is 0 and everything in bracket here becomes 0. So 0 times y will also be 0. It means that u, which is sine 2y will just be equal to what? P of y. So given the boundary conditions that at x equal to 0 and u equals sine y, it implies that P of y is equal to what? Sine y. I just explained that. Plug in 0 here, everything becomes 0. Everything becomes 0. So P of y will be equal to what? The sine y. That gives the solution as u equals y into x to the power of 4 over 3 minus x squared over 2. This is x squared over 2 plus x cos 2y plus p of y, which is what? Sine y. This is how we do partial integration. Yeah. Don't forget to subscribe, don't forget to like, and don't forget to share this video to your friends and to your classmates. I remain the complex analyzer. See you in the next video. Stay tuned. Keep watching.